Chapter 1, Exercise 18. Hence, since x dot product y equals 0 is equivalent to x1 y1 plus x2 y2 plus and so on plus xk yk equals 0, the problem reduces to solving one equation with respect to k unknown variables y1 and so on yk. Since k greater than or equal to 2, a non-zero solution y exists. In the case k equals 1, use proposition 116b. Solution. Let x equal x1 and so on xk element rk. If x equals 0 vector, then all xj equals 0, j greater than or equal to 1 less than or equal to k, and arbitrary non-zero y satisfies the needed condition. Assume that x not equal to 0 vector, and let j n be two distinct indices such that xj doesn't equal 0. Such indices exist since k greater than or equal to 2. Define JL equals, if L equals n, -1, if L equals j, xn over xj, if L not element of j or n, 0. Then y equals y1 and so on yk is non-zero, and x dot product y equals minus xn plus xj xn over xj equals minus xn plus xn equals 0. In the case k equals 1, the result is no longer true. By proposition 116b, if x, y in R, x not equal to 0, y not equal to 0, then xy not equal to 0. Comments. Non-zero vectors xy in Rk are called orthogonal if the angle between them is a right angle. This is equivalent to say that the triangle formed by zero vector x and y is a right triangle. The length of the hypotenuse of this triangle equals 2 absolute value x minus y. In this case, by Pythagorean theorem, absolute value x minus y squared equals absolute value x squared plus absolute value y squared. Since absolute value x minus y squared equals absolute value x squared minus 2 times x dot product y plus absolute value y squared, we find that x dot product y equals 0. The result of this exercise has the following geometric interpretation. If k greater than or equal to 2, then there are non-zero vectors orthogonal to x. In fact, if x does not equal 0 vector, then all vectors that lie in some subspace of dimension k minus 1 greater than or equal to 1 are orthogonal to x. Since the dimension of the real line R is 1, there are no non-zero points y that are orthogonal to a non-zero point x. A. Orthogonal vectors in R2. B. All vectors orthogonal to x belong to the red plane. Thanks for watching.